There are few things more humbling than staring into the night sky and realizing just how small we are. Out there, beyond the comfort of our warm, blue planet, lie worlds so extreme, so violent, and so ancient that they defy imagination. Planets where it rains molten rock, where stars devour their children, where darkness stretches for billions of miles with no end in sight. It would be difficult to find anyone who has truly contemplated the scale of the cosmos without feeling a chill deep in their bones. And yet, in that vastness, there is beauty, a kind of terrifying elegance. Each of these strange and distant exoplanets tells a story, not just of physics and orbit, but of chaos, destruction, endurance, and time. They are not just places. They are mirrors held up to our fears, our questions, our wonder. In this journey, we will visit 6 of the most extraordinary worlds ever discovered, planets that feel more like science fiction than reality. But they are real, and they are waiting. Imagine standing on the surface of a distant world, where the moment the sun peeks over the horizon is the last moment of your existence. The air does not warm, it scorches. The light does not gently rise, it vaporizes everything it touches. Rocks do not rest on the ground. They rise as vapor, then fall back as a deadly rain of molten stone. There is no shelter here. Not even the strongest umbrella forged by human hands could shield you, unless it were made of titanium. This is not the setting of a science fiction horror tale. This is a real place in our universe. This is Corot 7b. Corot 7b lies in the constellation Monoceros, the unicorn, roughly 500 light-years away from Earth. It was one of the first rocky exoplanets ever discovered, and it opened a new chapter in our exploration of worlds beyond our solar system. Although it is only slightly larger than Earth, this planet could not be more different. With a radius about 1.5 times that of our world, and an estimated age of 1.5 billion years, Corot 7b is a young and violent planet, forever locked in a deadly dance with its parent star. What makes Corot 7b so terrifying is its position. The planet orbits incredibly close to its host star, about 60 times closer than Earth is to the Sun. This tight orbit means that the planet is tidally locked, with one side constantly facing the star, while the other remains in eternal darkness. The side exposed to the star experiences temperatures reaching 2,600 degrees Celsius, or about 4,700 degrees Fahrenheit, hot enough to melt rock, vaporize metal, and erase the line between solid and liquid. At that proximity, the parent star appears 360 times larger in the sky than our Sun does from Earth. Daylight on Corot 7b is not just intense, it is apocalyptic. The planet's surface is a furnace where rocks sizzle, mountains drip into lava seas, and the atmosphere is a swirling soup of metallic vapor. Meanwhile, the night side, hidden from the star's reach, plunges into frigid darkness. Temperatures can fall to minus 235 degrees Celsius, or about minus 390 degrees Fahrenheit. Perhaps the most surreal aspect of Corot 7b is what happens when rock turns into weather. On the day side, rock is not solid, it boils. Vaporized minerals rise into the upper atmosphere, carried by brutal thermal currents. There, far above the blistering surface, the rock vapor cools and condenses into tiny mineral fragments, like gravel suspended in midair. Then, as the atmosphere shifts, these particles fall back to the surface in a brutal meteorological event, a literal rain of stone. On this planet, rain does not bring water, it brings shattered Earth itself. Some scientific models suggest that oceans of lava may stretch across the day side of Corot 7b. These fiery seas, constantly churning and evaporating, may define much of the planet's geology. Unlike Earth, which cools through tectonics and weather, Corot 7b exists in a perpetual meltdown. The extreme temperature difference between the hot and cold sides creates intense winds, perhaps powerful enough to circulate vaporized rock around the entire planet. On the night side, frozen mineral gases might coat the surface, turning into exotic frost made of once molten stone. COROT. 7b is not a place we could ever hope to visit. It is a world forged in fire, sculpted by tidal forces, and punished endlessly by the fury of its nearby sun. And yet, it exists, a real planet in our galaxy, reminding us that the laws of nature do not favor comfort or familiarity. They favor extremes. This is just one example of how bizarre and violent exoplanets can be. And if you think rock rain is terrifying, wait until you see what happens when a planet grows rings bigger than the orbit of Mercury. Corot 7b may seem like a small, tortured rock today, but once, it might have been a giant. Some astrophysicists believe this hellish world began its life as a gas giant, one that could have been up to 100 times the mass of Earth. In its youth, it may have resembled Neptune or even Jupiter, wrapped in thick layers of hydrogen and helium. But as it drifted closer to its star, that ancient atmosphere stood no chance. The intense radiation and stellar winds blasted it away, peeling off layers like smoke in a hurricane. Over time, the once massive envelope of gas was stripped away entirely, leaving behind only the dense, rocky core. This core, once buried beneath clouds and storms, is now exposed, naked to the brutal light of its star. What remains is a planetary skeleton, a relic of a transformation few worlds survive. In a way, Corot 7b is not just a planet, it is a monument to destruction. It tells the story of what can happen when gravity wins the battle, but radiation writes the final chapter. The planet itself is a fossil of cosmic violence. The orbit of Corot 7b is more than just tight, it is deadly. At such close range, the forces acting upon the planet are so strong that it may still be losing mass today. Some scientists suspect that even now, minerals are evaporating into space, forming a thin tail trailing behind the planet, like the remnants of a burning comet. It is as though the star is still feeding, still pulling the remains of a former giant into its infernal heart. The past is not over here. it continues to be written in heat and ash every single day. When we speak of beauty in space, we often picture swirling galaxies or serene blue worlds. But nature is not always gentle. Sometimes, nature is violent, merciless, and raw. Corot 7b is not beautiful in the way Earth is, but it is sublime in its extremity. It exists because the universe allows it to exist. It suffers because the universe does not care. And yet, that very indifference is what makes it so fascinating. It is a laboratory of physics, an open wound in the face of creation, where light and gravity dance with destruction. On Earth, we are blessed with a delicate balance: warmth without fire, air without poison, sunlight that nurtures rather than burns. Corot 7b reminds us how rare that balance may be. For every world like ours, there could be thousands like it, scorched, stripped, and silent. It forces us to ask, is life an accident or an inevitability? Is Earth a sanctuary or an exception? In the molten echoes of this distant world, we may find a deeper appreciation for our own. The universe is not designed for comfort, and yet here we are, against all odds. Corot 7b is a furnace, a stone caught too close to a star. But in its blazing silence, it speaks volumes. It shows us that planets are not born gentle. They are forged, tested, and sometimes destroyed. It shows us that existence itself is a rare and fragile fire. The universe offers no promises, but it does offer truth. And sometimes, that truth is found in places where rock turns to rain, and light becomes death. From such terrifying beauty, we learn not only what is out there, but why what we have here matters. When we think of majestic planetary rings, our minds turn to Saturn, its icy loops stretching across hundreds of thousands of kilometers. But what if we told you that Saturn's rings are nothing more than a decorative bracelet compared to the colossal crown worn by another world? Welcome to J1407b, an exoplanet that may possess the largest ring system ever discovered in the known universe. Imagine rings so vast that they would stretch farther than the distance between Earth and the Sun. This is not exaggeration, it is reality, shimmering hundreds of light years away. J1407b orbits a young star in the constellation Centaurus, roughly 400 light-years from Earth. Discovered not through direct imaging, but through unusual patterns in light, this world puzzled astronomers from the very beginning. Its mass is still uncertain, estimated to be somewhere between 10 and 40 times that of Jupiter. That range alone leaves open a fundamental question. Is this a super-Jupiter gas giant, or is it something far stranger? Some even argue it may be a failed star in disguise, but all agree, whatever it is, its rings are its defining glory. The rings of J1407b are not just wide, they are absurdly, almost mythically enormous. There are an estimated 30 individual rings, each one composed of ice, dust, and rocky debris. Together, they span a diameter of nearly 180 million kilometers, greater than the full distance between Earth and the Sun. If J1407b were placed in the middle of our solar system, its rings would reach beyond the orbit of Venus. To call them breathtaking would be an understatement. These are cosmic structures of cathedral-like scale. Despite their size, the rings of J1407b are surprisingly light. Their combined mass is estimated to be a small fraction of Earth's, roughly equivalent to a single large moon. But what makes them so noticeable is their shadow. When the rings passed in front of their host star, they caused dramatic dimming events, with complex light curves revealing gaps and structures within the rings. This was how the planet was discovered, not by its glow, but by its eclipse. The planet did not shine, it cast a magnificent shadow. How does a planet acquire rings so immense? One leading theory is that they are the aftermath of a violent collision, perhaps between large moons or between a satellite and the planet itself. The debris from such an impact could have spread out into orbit, forming concentric rings through gravitational shaping. Another possibility is that the rings are ancient leftovers from the planet's formation, never condensed into moons due to tidal forces. Either way, these rings may be temporary, eventually coalescing into satellites, or slowly fading into space dust. Some scientists propose that we may be witnessing a planetary system in its formative stage. Within the rings are noticeable gaps, regions where material appears to be missing. These gaps could mark the birthplaces of exomoons, slowly sweeping up the dust and ice around them. It is a cosmic nursery, sculpted by time and motion. If Saturn is a portrait of what ringed planets become, then J1407b is a glimpse into what they were. In its rings, we may be seeing the raw process of planetary evolution unfolding before our eyes. There is still debate about what J1407b truly is. While many classify it as a super Jupiter, a gas giant several times the mass of Jupiter, others argue it may not be a planet at all. Instead, it could be a failed star, a protostar that never ignited. These are known as brown dwarfs, and J1407b sits dangerously close to the boundary. Its mass, its temperature, and its gravitational influence all hint at a strange middle ground. It is not quite a star and not entirely a planet. It may be something else entirely, something in between. The vast ring system of J1407b is not uniform. There are gaps, dark voids in the otherwise continuous bands of dust and ice. These gaps suggest something massive passed through, carving a path like a boat through water. One theory proposes that a moon the size of Mars may have once orbited the planet before being shattered by tidal forces or an ancient impact. The debris from such a collision could have spread outward, forming the rings we see today. If true, then we are not just seeing a ring system, we are witnessing the scars of planetary violence. J1407b was not discovered through direct imaging. It was found by studying light. As the planet and its rings passed in front of their host star, they blocked the starlight in complex and irregular patterns. These patterns, deep dips, shallow fades, and rapid fluctuations, told a story of layered structures and moving parts. From Earth, it looked as if the star itself was flickering. But behind that flicker was a colossal planetary system, invisible to the eye, yet powerful enough to cast a signature across light years. The planet revealed itself not by shining, but by eclipsing. If Saturn is the jewel of our solar system, then J1407b is the cathedral. Its ring system is not just vast, it is magnificent in its complexity. Imagine standing on a moon orbiting the planet, looking up to see arcs of stone and ice stretching across the sky, spanning millions of kilometers from horizon to horizon. This is not a landscape we could ever walk, but it is one we can imagine, a reminder that the universe is capable of beauty beyond anything we have seen on Earth. It is cosmic architecture on a scale beyond comprehension. J1407b challenges our understanding of planets, of stars, and of what lies in between. It reminds us that the cosmos is filled with wonders that defy easy labels. A planet that may be a failed star, rings that may become moons, shadows that reveal more than light. Perhaps that is what makes this world so captivating, not just its size, but the questions it forces us to ask. What else is out there, waiting behind the veil of starlight? What other giants wear crowns too vast to see, unless we know exactly where and how to look? Imagine a planet without a sunrise, no dawn to break the night, no star to warm its skies. A place adrift in the cosmic ocean, forgotten by the very system that once gave it birth. It spins endlessly through the blackness, illuminated only by its own fading heat. This is not the distant vision of science fiction. It is a real planet, one that does not belong to any solar system. It is called PSOJ 318.5-22, a rogue planet, wandering alone through the dark corridors of the galaxy. PSOJ 318.5-22 lies about 80 light-years from Earth in the direction of the constellation Capricornus. It was discovered in 2013 by the Pan-STARRS telescope, not by watching it pass in front of a star, but by detecting the faint infrared glow it emits. This planet is roughly 8 times more massive than Jupiter and incredibly young, only around 12 million years old. It is not tethered to any star. It drifts freely, a world without a home, cast out into the vast and empty dark. Most exoplanets are difficult to study because the glare of their host stars overwhelms the light they reflect. But PSOJ 318 has no such star. For astronomers, that is a gift. With no solar interference, this planet can be directly observed in the infrared spectrum. It glows faintly with its own retained heat, like a dying ember in the night. This rare circumstance has allowed scientists to analyze its atmosphere, study its rotation, and even glimpse the weather on a planet dozens of times farther than the edge of our solar system. PSOJ 318 is not quiet. Beneath its cool, dark surface lies a chaotic world. Observations show it completes a full rotation in about 5 hours, meaning its days are among the shortest of any known planet. Its atmosphere is thick and turbulent, layered with clouds of dust and vapor. Temperatures reach well above 1,000 degrees Fahrenheit. Scientists believe the planet is home to brutal storms, where molten iron may condense into clouds, rise high into the atmosphere, and fall again as metallic rain. It is not just lonely, it is violent and alive. For the first time in astronomy, scientists have been able to model weather patterns on an exoplanet without a parent star. Infrared readings reveal not only temperature, but the movement of clouds and atmospheric systems. These clouds may swirl at speeds faster than sound, forming jet streams of dust and metal across a sky that never knows daylight. It is a planet sculpted by internal heat, not starlight, a furnace sealed in darkness. The absence of a star does not bring stillness. Instead, it reveals a kind of restless fury hidden in the shadows. There is something haunting about a planet that orbits nothing. No seasonal change, no tides, no solar eclipse. Just motion through a void where no sun ever rises. And yet, PSOJ 318 speaks to us more clearly than most. In its isolation, it offers a glimpse into the early chaos of planetary systems, or perhaps the lonely fate that awaits some worlds. It is a reminder that not all planets live in harmony. Some are cast away, some travel alone, and in doing so, they become monuments to the vast, indifferent canvas of the cosmos. How does a planet end up alone in space, drifting without a sun? There are two main theories. The first suggests that PSOJ 318 may have formed like a star through the collapse of a gas cloud, but without gathering enough mass to ignite nuclear fusion. The second theory is more dramatic. It proposes that this planet once belonged to a young star system, but was violently ejected after a chaotic gravitational encounter with a larger neighbor. Flung away like cosmic debris, it now wanders the galaxy, exiled by the very forces that gave it life. If PSOJ 318 was formed in isolation, is it really a planet? If it was born from stellar collapse but never ignited, is it actually a brown dwarf, a failed star? Astronomers face a difficult question. Should classification depend on how an object forms or what it becomes? With a mass near the boundary between large planets and small stars, PSOJ 318 lives in a gray zone. It is too massive for comfort, too quiet for ignition, and too free to be easily named. Sometimes the universe creates things that defy our categories and remind us of our limits. For most of history, rogue planets were considered exotic outliers, rare anomalies in a mostly orderly universe. But recent studies suggest they may be far more common than we imagined. Some estimates propose that for every star in the Milky Way, there may be several rogue planets. That means hundreds of billions of worlds, drifting through the cold dark without a home. PSOJ 318 is not an exception. It may be one of the first members of a vast and hidden population. These planets are not accidents. They are part of the structure of our galaxy. Although they are difficult to find, rogue planets are scientific treasures. Because they are not overwhelmed by starlight, they can be observed more directly in the infrared spectrum. Their atmospheres, temperatures, and compositions can be studied with greater clarity than planets orbiting stars. By examining objects like PSOJ 318, scientists can test models of planet formation, migration, and system instability. Each rogue world is a fossil of cosmic history, a record of turbulence, disruption, and survival. They are, quite literally, worlds without borders. PSOJ 318 is a silent traveler, adrift in a universe that does not miss it. There is no warmth here, no cycle of day and night. It is a world where light never rises, and shadows are endless. And yet, this planet exists. It persists in spite of isolation, carried forward by the same physics that holds galaxies together. It is a stark reminder that the universe is not built for comfort or meaning. It simply is. And in that indifference, there is something profoundly humbling, a beauty that exists without asking to be seen. We often look to the stars with a sense of wonder, imagining life, warmth, and connection. But planets like PSOJ 318 show us another truth, that the universe is not obligated to be kind. Some worlds never find a star, some never feel light, and yet, in their loneliness, they tell stories no other planets can. They show us what it means to exist without purpose, without a system, without a center. And perhaps, in reflecting on that emptiness, we come to value our own fragile place in the cosmos even more. Imagine a world so close to its star that it is being pulled apart, grain by grain, in a slow and silent collapse. Imagine looking up from its surface and seeing a sun so near, so large, that it fills the sky with fire and with hunger. The light does not just burn, it devours. This is not the poetic image of a dying star. This is the real fate of a doomed planet. Its name is WASP-12b, and it is one of the few worlds we have found that is not just orbiting, it is being consumed. WASP-12b is a gas giant located nearly 900 light-years from Earth. It is nearly twice the radius of Jupiter, making it one of the largest exoplanets ever observed. What makes it truly remarkable, however, is its proximity to its star. This planet completes a full orbit in about 1 Earth day. That means it is close, so close that the heat, radiation, and gravitational pull from the star distort its very shape. WASP-12b is not a sphere. It is stretched like an egg, locked in a desperate orbit around a blazing furnace. The tidal forces acting on WASP-12b are among the most extreme known. The intense gravitational difference between the side facing the star and the far side of the planet causes the atmosphere to bulge outward. It is as if the planet is being pulled like dough, stretched until it breaks. And it is breaking. Streams of gas and vapor are escaping the planet's gravity, flowing toward the star in an invisible current of loss. The planet is literally falling apart, slowly being shredded by the very force that holds it in place. Until recently, such destruction was only theorized in binary star systems. But WASP-12b is the first known case where a star is actively consuming a planet. This phenomenon, mass transfer from a planet to a star, was once considered impossible. Yet here, it happens in real time. The star feeds on its companion, drawing atmosphere and energy into itself. This is not a stable orbit, it is a death spiral. The planet grows hotter, more unstable, and more vulnerable with each passing day. It is not merely orbiting, it is being eaten alive. The more matter the planet loses, the faster it falls. The gravitational interaction between the star and WASP-12b causes the planet to spiral inward, tightening its orbit and accelerating its demise. This is a feedback loop of destruction. The closer it gets, the more it burns. The more it burns, the faster it falls. In less than 10 million years, a blink in cosmic time, the planet will no longer exist. All that will remain is a faint cloud of dust and gas, slowly fading into the stellar winds that once stripped it bare. What we see in WASP-12b is more than a planetary death. It is a warning, a demonstration of the delicate balance that defines planetary life. Orbit too far, and you freeze. Too close, and you perish. This planet walks that razor's edge and loses. It is a portrait of vulnerability, played out on a cosmic scale. And as we peer across the darkness of space, watching this world fall apart under the pull of its own star, we are reminded just how rare it is to orbit at just the right distance, in just the right moment. The surface of WASP-12b is a vision of true hell. With temperatures soaring above 2,000 degrees Celsius, more than 4,000 degrees Fahrenheit, the planet is bathed in constant searing radiation. At this level of heat, molecules break apart, metals vaporize, and the atmosphere becomes a toxic swirl of carbon monoxide, methane, and elemental gases. It is not a place where life can survive. It is not a place where matter remains stable. This is not just heat, it is disintegration. A furnace so intense, it erodes identity itself, turning atmosphere into ash. What lies beneath that inferno may be even stranger. Based on the planet's unusual carbon-to-oxygen ratio, scientists believe that WASP-12b could contain an interior rich in carbon. So rich, in fact, that its core might be composed of crystalline graphite or even diamond. This speculation has earned it the nickname the Diamond Planet, though the truth remains uncertain. Whether or not diamonds exist within its core, the possibility stirs the imagination. A world being torn apart, glittering inside with unimaginable pressure and carbon, beauty dissolving in real time. In the swirling gravitational chaos of this system, there may be another body, a suspected moon orbiting the planet itself. Preliminary data suggests the presence of a satellite nearly 7 times the size of Earth's radius. If it exists, it too is locked in a doomed orbit, bound to a planet that is itself bound to destruction. We do not know much about this possible moon, not even whether it truly exists. But the idea of a moon circling a dying world, both drawn toward annihilation, paints a haunting picture of gravitational loyalty. WASP-12. B is not falling all at once. It is dying slowly, and that slowness is its poetry. Every orbit draws it closer, every loss of mass accelerates the end. It does not rage, it erodes. It does not explode, it fades. This is not death in violence, but death in submission. The planet gives itself up, little by little, to the pull of the thing it orbits. The star, once its anchor, is now its executioner. And yet, the two continue their ancient spiral, locked in motion, bound by physics, indifferent to outcome. There is something terrifying about a force that does not hate, does not love, but simply consumes. Gravity is that force. WASP-12. B is caught in a slow dance with a star that does not even notice it is destroying its partner. There is no malice here, no will, only mechanics. And that is what makes it so tragic. The planet is being undone not by choice, but by nature. This is the cost of imbalance, the price of getting too close to the fire. In this, WASP-12b becomes more than a planet. It becomes a lesson. In its destruction, WASP-12b teaches us something about the universe. That beauty and death can exist in the same orbit. That even in collapse, there is structure. That sometimes what vanishes still leaves behind a story. As it spirals into its end, trailing gases like a comet without hope, the planet writes a poem in heat and light, a final act we are lucky enough to witness from afar. It is not a world we can save, but it is one we can remember. A symbol of how delicate, how dramatic, and how temporary existence can be. Imagine discovering a planet, naming it, studying its orbit, estimating its mass, and then watching it disappear. Not drift away, not grow dim. Disappear. Fomalhaut b, once celebrated as one of the first exoplanets ever directly imaged, stunned the world of astronomy, not because of what it was, but because of what it became. Nothing. A ghost in the data. A memory on a telescope lens. It was a world that invited headlines, debate, and admiration, until it faded like a mirage, leaving behind only questions. The story began in the early years of the new millennium, when the Hubble Space Telescope captured images of a massive disk of dust encircling the bright nearby star Fomalhaut. That alone was intriguing. It hinted at a young planetary system in formation. But then, among the scattered reflections of light, astronomers saw something different. A small, bright object within the disk. It appeared to move, to orbit. It was given a name, Fomalhaut b. The world rejoiced. This was among the first times humanity had seen another planet directly. But almost immediately, something was off. Fomalhaut b did not behave like a typical planet. It emitted no infrared heat signature, which was unusual for an object presumed to be several times the size of Jupiter. Its orbit was erratic, changing faster than models predicted. The object itself grew in apparent size while becoming dimmer, an inverse relationship that defied expectation. It was as if the planet was expanding and dissolving at the same time. Astronomers were intrigued, puzzled, and increasingly uneasy. Planets were not supposed to act this way. By the year 2014, the mystery deepened. The bright dot that once stood proudly in Fomalhaut's disk began to fade. By 2020, it was gone. Completely. Observations from Hubble showed that the object had expanded, thinned out, and vanished. There was no remaining trace of a planet, no gravitational disturbance, no reflection, no orbiting body. What had been studied, catalogued, and modeled as a planet was, evidently, nothing of the sort. Fomalhaut b had not died. It had never lived. It was, in the eyes of science, unmade. What scientists now believe is both humbling and fascinating. Fomalhaut b was likely not a planet at all, but a transient dust cloud, the debris left behind from a massive collision between two asteroid-sized bodies. That would explain the light, the size change, the lack of heat, and the disappearance. The perfect timing of Hubble's observations had caught this event at just the right moment, turning it into an illusion of a world. It was not a planet. It was an accident of perspective, a brief, bright echo of chaos mistaken for creation. Fomalhaut b remains a sobering reminder of how easily we can mistake shadow for substance. In our hunger to find other worlds, we sometimes see what is not there. But these moments of error are not failures. They are milestones. They remind us that the universe is not a clean machine, but a wild and unpredictable canvas. Fomalhaut b may not be real in the way we hoped, but its disappearance left something behind. A deeper understanding of planetary formation, and a beautiful warning that even science is not immune to illusions. After years of uncertainty, a new theory emerged, one that stripped Fomalhaut b of its planetary title. Astronomers now believe that the bright object once thought to be a planet was in fact a short-lived dust cloud. This cloud may have formed from the catastrophic collision of two icy bodies, perhaps protoplanets or large asteroids, within the disk of debris surrounding the star. The flash of light, the changing shape, the fading signal, it all made sense in this new context. It had never been a planet. It had always been a moment. The fading brightness and expanding structure were exactly what one would expect from a rapidly dispersing dust cloud. There was no core, no gravity-bound object, only fragments, drifting and dissolving into space. What had once been celebrated as a new world was instead the wreckage of a cosmic accident. And yet, in this realization, there was no disappointment. Science had not lost a planet. It had gained a front-row seat to one of the rarest phenomena in astronomy. the immediate aftermath of a planetary scale collision. Fomalhaut B became a symbol not of what we got wrong, but of what we were able to see. Mistakes in science are not failures, they are doors. Misinterpreting data can lead to deeper questions, better tools, and sharper understanding. By chasing the illusion of a planet, astronomers ended up capturing something far more elusive, a real-time snapshot of destruction in a young star system. This fleeting dust cloud gave us insight into how planetary systems grow, break apart, and evolve. It was never a planet, but it taught us how planets live and die. There is something poetic about Fomalhaut B. It appeared when we needed it most, when we longed to see new worlds with our own eyes. It gave us hope, then confusion, then humility. Like a ghost, it left behind no bones, no structure, only a fading signature in light. It reminded us that the universe is filled not just with solid matter, but with events, ephemeral, chaotic, unrepeatable. Fomalhaut B was never meant to last. It was a flash of dust and data, interpreted through the lens of our expectations. The story of Fomalhaut B forces us to confront a hard truth. What we call reality is often just the best version of the data we have. Sometimes, what seems solid turns to mist. What seems eternal flickers out. In this vast and ancient cosmos, truth is rarely absolute. It is built, refined, and sometimes torn down. Fomalhaut B reminds us that science is not about certainty. It is about pursuit. And in that pursuit, even illusions matter, because they reflect the boundaries of what we are able to imagine. Fomalhaut B may be gone, but its lesson remains. Not every discovery will last. Not every image will hold. But each one brings us closer to understanding how the universe works and how easily it can surprise us. In the end, Fomalhaut B was not a planet. It was a question, a challenge, a beautiful mistake that expanded the horizon of what we thought we knew. And sometimes, in the endless darkness of space, a question is more powerful than any world. Imagine a world so ancient that it may have witnessed the birth of galaxies, the rise of stars, the quiet unfolding of the universe itself. While most planets we study are young in cosmic terms, there is one that stands apart, not for its light, not for its size, but for its age. Captain B is not just a planet, it is a survivor. It has existed since long before our sun ignited, before Earth formed, before life as we know it began. It is a planet that carries time within its orbit. Captain B orbits a faint red subdwarf named Captain, located about 13 light-years from Earth in the southern constellation Pictor. This star is not bright or majestic. It is small, cool, and old. In fact, it is one of the oldest stars near our solar system, estimated to be over 11 billion years old. Captain likely formed when the Milky Way was still gathering its shape. It is a relic from an earlier age of the universe, and the planet it carries has likely been traveling with it through billions of years of galactic history. Despite its proximity to the star, Captain B lies within the habitable zone, the region where temperatures may allow liquid water to exist. That is possible only because Captain is so dim and cool. While the planet orbits much closer to its star than Mercury does to the Sun, it receives just enough energy to keep its surface within a range that scientists believe could support water, from about -50 degrees to 10 degrees Celsius. It is a narrow window, but in cosmic terms, even a sliver of possibility can mean everything. Captain B is not remarkable for its geology, its atmosphere, or its storms. What makes it extraordinary is its timeline. Earth has existed for about 4.5 billion years. Life here has evolved from simple cells to thinking minds in that time. But Captain B is nearly twice as old. If life began there, it had a head start of billions of years. Time enough not just for microbes, but for complexity, for ecosystems, for civilizations, perhaps even for extinction. If anything lived there, it may have looked at our system and seen only gas and dust. To survive for over 11 billion years is no small feat. The planet has withstood supernovae, galactic collisions, and the slow violence of time. And it has done so while staying in a narrow zone of habitability, with just enough energy to hold the possibility of liquid water. The longer a planet remains stable, the more likely it is that life, if ever sparked, has the chance to evolve. Captain B is not a promise, it is a question. What could have happened if life had not just millions, but billions of years to grow? We do not yet know whether Captain B has an atmosphere, or oceans, or even a rocky surface. But what we do know is enough to provoke wonder. It is ancient, it is stable, it lies in a zone where water might flow, and above all, it has lasted. Perhaps it is nothing but frozen stone, or perhaps it once teemed with life long since faded. Either way, it reminds us that the universe does not just create new things, it also preserves the old. Sometimes, the most profound discoveries are not in the distant future, but in the deep past. Captain B may not have been born in the quiet corner of space where it now resides. Evidence suggests that its parent star, Captain, was once part of a much smaller galaxy, one that collided with the Milky Way billions of years ago. This ancient, now dismantled dwarf galaxy, called Gaia Enceladus, was torn apart by gravity, scattering its stars into the growing spiral arms of the Milky Way. Captain was one of those survivors, and the planet that followed it, Captain B, is a galactic exile, carrying with it the memory of a vanished world. If Captain B ever supported life, it might have begun at a time when the Earth did not even exist. While our planet is still in its youth, this ancient world had eons, billions of years, to host life, evolve it, and perhaps watch it fade. We often imagine ourselves at the center of cosmic time, but Captain B reminds us that we may be the latecomers. It is humbling to consider, if a civilization once existed there, it might have risen and fallen while Earth was still dust and darkness. We may be hearing echoes of something long lost. There is much we do not know about Captain B. We do not know if it has an atmosphere, if it holds water, or if its surface is barren and cold. We have no images of its mountains, oceans, or skies, if any exist. All we have are shadows in data, whispers in spectra, and a growing sense of awe. But sometimes, the unknown is what gives a place its meaning. Captain B is a question stretched across time, one that science cannot yet fully answer. Its silence speaks volumes, and what it hides may be more profound than anything we could expect. Captain B is not remarkable because it shines or because it roars with storms. It is remarkable because it endures. It has seen the universe in its youth, survived collisions of galaxies, and now drifts quietly near our cosmic neighborhood. It may be lifeless. It may hold secrets. But above all, it is a monument to time itself. In a universe that burns bright and dies fast, Captain B has persisted. And in its persistence, it teaches us that age is not just a number. It is a story, and that story may yet have chapters to reveal. Across this cosmic journey, we've witnessed planets where rocks fall from the sky like rain, where rings stretch beyond the orbit of Earth, and where worlds are swallowed whole by the stars they once orbited. We've seen solitary giants drifting in darkness, ghost planets that never truly existed, and ancient Earth-like worlds that may have carried the seed of life long before our own blue planet cooled from fire. Each of these worlds feels like science fiction, and yet they are all real, floating silently through the same galaxy we call home. The more we learn about them, the more we're reminded that the universe isn't bound by our imagination. It far exceeds it. These planets challenge everything we thought we knew about what a planet could be. Some defy the laws of survival, others the laws of formation. They teach us that planetary systems are not static. They grow, collide, dissolve, and reform. And more importantly, they teach us that the search for life isn't just about finding copies of Earth, but about understanding the vast diversity of environments where life might take hold in ways we haven't even begun to grasp. They push the boundaries of science, yes, but also of wonder. Because behind every telescope image, behind every light curve and spectral reading, is the hope that something, or someone, might be out there looking back. And so, as we end this journey across lava worlds, rogue giants, diamond storms, and vanished ghosts, we're left with one truth. The universe is stranger, older, and more alive than we ever imagined. These aren't just distant rocks in space. They are chapters in a cosmic story still being written. With every discovery, we turn a new page, expanding not just our scientific horizons, but our understanding of what it means to exist in this vast, expanding ocean of stars. The next time you look up at the night sky, remember, the real question isn't whether we are alone. The real question is, How many strange and beautiful worlds are still waiting to be seen? If you enjoyed this video, please give it a like and subscribe to our channel. Let us know your thoughts in the comments. We'd love to hear from you. Thanks for watching, and we'll see you in the next one.